Hi everybody, in this week's episode of Gaffer and Gear we're going to talk about running HMIs off portable generators. So we're going to cover things like why you can't run an M18 off a 2 kVA generator. We're going to cover things that you need to be aware of with the lights and things you need to be aware of with the generators. Alright, so let's talk about the generators first, because that's where the most misperception is. So a lot of people have a misperception of how much power comes out of the generator and for how long. So they're the two things we need to discuss. Okay, so basically I'll get into the maximum ratings of the generators first. So this is a 2 kVA generator, so that's a maximum that it's rated at. This is a 3 kVA generator, that's the maximum it is rated at, and I'm sitting on a 7 kVA generator, which is the maximum it is rated at. So how do they come up with these maximum ratings? Well, there is a formula or a test scenario that they use. Basically, it's the most amount of power that the generators can generate for 20 minutes of continuous running and then generate for another 20 minutes of continuous running after they've been turned off for 40 minutes. So I'll just run you through that again. So this is a 2 kVA generator. That means it can generate a 2000 watt load for 20 minutes. And then if you turn it off and let it cool down, you can do the same thing again for another 20 minutes. So that's how they come up with the maximum rating. So that's fantastic if your shoot goes for 20 minutes, but if your shoot goes for longer, then you need to know the rated output of the generator or the constant load rating of the generator. So it'll either be called one of those two things. Now, some generators have it written on it and other generators will have the information online or in the instruction manual. Now, to give you some idea, the 2 kVA generator here has a constant load rating of 1600 watts. So it definitely won't run an M18. The 3 kVA here has a constant load rating of 2600 watts, and the constant load rating of the 7 kVA that I'm sitting on is only 5500 watts. So what does that mean? Well, basically, if we're running the light continuously from the start of the day to the end of the day, that rating system is what the generator can output. All right, so that's only half of the complication. Now we're going to talk about the lights themselves. So there is a huge misperception with HMIs that when you say things like 1.2K, 1.8K, 2.5K and 4K, that you're talking about the total power draw of the light. And this is not the case. We're actually just talking about the lamp or the globe itself. So for example, this is a 1.8K lamp. But in order for this to work, you also need a ballast. This thing uses electricity as well. So your power draw is this plus this. So this is where things get very muddy because not all ballasts are as energy efficient as each other. To some degree, as ballasts get older, they can draw more power if they need components replaced. But the biggest difference from one ballast to the next is what we call power factor. So power factor is a little bit difficult for someone who's as dyslexic as me to explain. So I've put a link in the description. Click on that and it'll send you to another video where someone who's way more intelligent than me simply explains power factor. All right, so how do you tell if your ballast is power factor corrected or not? Well, here's the interesting thing. It doesn't matter if it's a big brand name. It doesn't matter if it's electronic. It doesn't matter if it's compact. It doesn't matter if it's got 1000 hertz mode. You can have all of these things and still have a ballast that is not power factor corrected. So how do you tell? Okay, well, some ballasts actually have it written on them. And ballasts that have a compliancy plate, if you have a read of the compliancy plate and you look for a cosine efficient symbol, that tells you the power factor rating. So what you're looking for is something above 90, ideally 95 and higher. Now, if that rating is below 90, I wouldn't bother trying to run it off a portable generator. Now, this is where it gets really interesting. Running a 1.8K or an M18 off a 3 kVA generator, one of these handy units. There's a lot of speculation on forums at the moment as to whether you can or cannot do this. So this is Gaffer's forums. So there's a whole stack of people saying, yeah, you can do it, piece of cake. The generator doesn't even rev hard. And there are other people saying that you can't do it, it just shuts down after a bit. This depends on whether your ballast is power factor corrected or not. And here's where things get really, really bad. When M18s or 1.8K HMIs first came out, there were a lot of ballasts made that were very, very small. So instead of being this size, this is a M18 ballast or 1.8K ballast, they were about here. So they were quite small, quite compact and quite lightweight. So how they got the weight down was really quite simple. They didn't put any power factor correction in them. Now, if you have a power factor corrected ballast, you can run an M18 off a 3 kVA generator, no problem at all. To give you some idea of the difference between power factor corrected and non-power factor corrected ballasts, this ballast here is 10 years newer technology, plus it's power factor corrected. It actually draws over 900 watt less power than the other ballast. 900 watt less. That's a lot on a 3 kVA generator. You can run a 1.2K HMI if it's power factor corrected off a 2 kVA generator. Off a 3 kVA generator, you can run an M18 if it's power factor corrected. And the 7 kVA I'm sitting on will run easily a 4K power factor corrected HMI. The next thing we'll talk about is linking generators together. So you can link two 2 kVAs together and you can link two 3 kVAs together. However, when you link two 2 kVAs together, you don't get a 4K. And when you link two 3s together, you don't get a 6K. Now, the reason for this is the generator that you turn on first is the master. Okay, so imagine that's the generator turned on, that's the master. The second generator you turn on is the slave. So the slave locks into the master. Okay, so they sync up. Now, the master always stays ahead of the slave when you're adjusting your power draws. Okay, so they don't share the load evenly. The master always draws more. So what that means is the master is going to hit its constant load rating or its peak load rating way before the slave. So they're not sharing the load equally. So what I've found is if I link two 2s together, I can run a 2.5K HMI as long as it's power factor corrected. If I link two 3 kVAs together, I can almost run a 4K. So what I mean by almost run a 4K is I can run it, but I have to turn the dimmer down just a little bit. So before we set some of these up, I just want to go through a couple of things with them. If the units are not fuel injected, which these two are not, you need to run it on level ground because it's relying on gravity to feed its liquids. So you've got to have it level. Even a slight angle will upset the generator over time. The next thing is don't run them indoors, which is why I've got the door open here. The carbon monoxide poisoning will kill you. The next problem I have with running these, particularly running them outdoors on cold days or on cold nights, is you get crew gather around the back of them because of the heat coming off the exhaust. You've got to clear those guys out because they're slowly giving themselves brain damage. And the next thing I want to point out is that these units, they do suck a lot of air. So I just want to show you how much air they pull. So if I put the side door on and I let go of the side door, okay, it falls away. So let's fire this thing up and see how much suction it has. So here's why I'm talking about the suction, and the suction really is the biggest cause of problems for me when these things come back from rentals. Number one problem is people try to soundproof these by building a box and putting it over the top. The box doesn't let air in, so the unit basically suffocates itself. The next problem is people putting them in car boots. Okay, so they run them inside a car boot to try and soundproof it, so they close the car boot. After about 15 minutes, this thing will choke out because it's recycling carbon monoxide or carbon dioxide. So that doesn't work. The next problem I have is people running these on beaches. They basically just go out, put the generator on the sand and turn it on, and then this thing basically sucks sand in through its air intakes and stops working. And I've had a few rentals where I've opened up the air filter and it's just full of sand. And the next one is one that has caught me out a few times, I've got to admit. It took me a while to figure out what was going on. And that was using these out in the rain. So I'd make a little bit of a rain jacket, no problem. But what I didn't realise was if I was using these on cement and the rain was hitting the cement and splashing, that splashing was getting sucked in through the air intakes and my air filter was getting wet. And when that happens, it can't breathe properly and it shuts down. So suction is something you've got to consider. The next thing to talk about is eco throttle. So basically, eco throttle determines whether the engine is running at a constant full speed or if the engine is allowed to rev down when there's not as much draw on the generator and then rev back up if more power draw is required. So the Eco Throttle has three advantages. It reduces your fuel consumption. It reduces the noise level off the generator because it's not running as hard, and it can increase the longevity of your motors because they're not running as hard. However, it does have some disadvantages depending on the situation you're working in. So one disadvantage is if the generator is running with the Eco Throttle turned on, and then a huge power load comes on, the generator momentarily can't keep up with the demand. So that can stall out your HMIs, can almost stall out the motor. Now, if your generators are not smart generators, if they don't have inverter systems, you can also get increases and decreases in voltage, so you can get spikes. So a good example of where to have the Eco Throttle turned off is if you're firing up a HMI, starting up a HMI that has a dual selection ballast, so something like, say, an M18, that fires up to a 1.2 first and then does a huge jump to 1.8. Okay, that huge jump can give you problems with the generators. Likewise, some 2.5 4K ballasts will fire up to 2.5K and then do a solid jump to 4. Okay, so in that situation, Eco Throttle can be a problem. There is one situation in which you absolutely want the Eco Throttle turned off. You want the generator running at maximum revs, and that is if you're doing a hot restrike. If you do a hot restrike and you've got the generator set to Eco Throttle, what can happen is the HMI will turn on, and then it won't get enough power and it will turn off, and then it will turn on, turn off, turn on, turn off, and you can damage your globe. So that is something you've really got to be careful with. My next bit of advice with hot restriking is wait as long as you possibly can before you do it. That enables the globe to cool down, reduces the power that you need to do the hot restrike, and gives the generator a better chance of delivering that power surge. Alright, so I've got a 2 kVA generator here and I'm going to use it to run a 1.2K HMI. So the first problem we have here is the ground is not level. So even though this doesn't look like much of a slope, it is enough of a slope that the generator will stop running in about 20 to 30 minutes. So when you go to level a generator out, don't mess around with wedges, because when the generator is running, it vibrates. So if you've got wedges on, it's just going to shake off the wedges. So you're going to need something a bit more substantial. Alright, now that I'm happy with how level that is, let's turn it on. So the first thing you've got to watch with these smaller generators is they have an air valve on top of the fuel lid. So make sure that's in the on position. If you don't, it'll run out of fuel in about 20-30 minutes. You'll end up with a vacuum in the fuel tank and the fuel won't get through to the motor. I've done this more times than I'd care to remember. Now the next thing to check is your throttle, your choke. So if the generator hasn't been used in a while, you're going to want the choke in the on position. But this was used about an hour ago, so I'm going to have the choke off. Okay, next thing is to turn the power into the on position, take up the tension on the rope and give it a pull. Now just a quick note, if you started the generator with the choke on because the engine was cold, make sure you turn the choke off before you continue. Alright, now that I've got it turned on, I'm going to let it run for about 2 to 3 minutes so that it warms up, and in the meantime I'll set up the HMI. So something that is worth pointing out is when you're wiring up a HMI, you should always start at the head and then work your way back to the power. So what I mean by that is you plug the head lead into the head first, then plug the head lead into the ballast, and then the last thing you do is plug the ballast into power. That way you don't get any surprises if you're working up here and you accidentally left the ballast in the on position. Now the next thing I'm going to do is make sure that everything on the ballast is in the off position before I plug it into the generator. Okay, now I fire up the ballast, wait for it to go through its start routine and fire up the HMI. Alright, now let's say we want to turn it off. My advice is don't press the off button on the ballast. Flick the breaker. So this is what I mean. Don't press this button, flick the main breaker off. Now the reason I suggest that you flick the breaker is if you have a generator that surges, that surge won't affect your electronics because your breaker is disconnected from the circuit. Now we're going to try a hot restrike, but I'm going to do it incorrectly. I'm going to leave the generator on eco throttle. Now this desisty ballast has a lot of protection in it, so if things go wrong, it'll just trip its breaker. Let's have a look. Alright, so now let's try that the correct way. So we're going to turn the eco throttle off, let the engine rev up in the generator and give it another go. Now, just a word of a warning there, if you tried that the incorrect way with other ballasts, there's a really good chance you could damage your globe or damage the electronics. All right, that was really straightforward. Now we're going to get a lot more complicated. We're going to try and run a 4K HMI off two 3 kVA generators. Now the first issue we have to deal with is these things are not fuel injected. So I'm going to have to make sure they're sitting level. Now remember earlier in the video, I said that these things suck a lot of air. Well, if I have them this close together, they're going to foul each other's air supply. So I also have to separate them. All right, now that I've got them leveled and separated, the next step is to plug in the link. Now plug in the link before you turn the generators on. That's very important. Now there are two types of links you'll come across. Standard link cable like this. I think this is called inverter link cable. With these cables, it doesn't matter which way you plug them into the generator, in terms of that way up or that way up. Makes no difference at all. Now, just to clarify that, that's if it's a floating neutral generator, which if you've just taken it out of the box from Honda, that's what it'll be, which means that the earth and the neutral are not bonded together, not connected inside the generator. Now, with my units, I have a link box made up. Okay, so basically that goes off to one generator, this goes off to the other, and this has the outlets that I require on it. Now, having said that, it doesn't matter which way you plug these in, I have color-coded mine. And the reason I color-coded them is when I was renting these things out and people were going to link them together, I'd get a phone call at like 2 a.m. in the morning asking if it matters which way I'll plug them in. So that's why I color-coded them, so someone didn't phone me up at 2 o'clock in the morning. They just followed the color coding, which doesn't matter. Okay, so let's plug these in. Okay, the next step is to make sure my valves are in the on position, so they're going to get their air. And then I set the start to the throttle position, the choke position, and give it a rip. Now I'm going to set up the HMI, get that all ready to go. Give these things time to warm up, and then we'll get through starting it. Now, just a very quick pickup shot to explain something with these generators. So if they're cold, you put them into the choke starter position, and then as soon as you fire it up, you put it into the on position. Now, before we start up, there's one more issue, and that is how this HMI fires up. So this one's going to slowly go up to 2.5K, and then it's going to jump to 4K. So if I leave these things in eco throttle, they could stall. So I've got to make sure I turn the eco throttle off on both the generators before I start up the HMI. Okay, now I'm ready to start the HMI up. Now I know from testing that these generators won't be able to take the load of this HMI at full power, so I have to dim it down a little bit. And now I can turn the eco throttles back on and save a bit of fuel. Now, if you've got two generators linked together and you're going to turn off a big load like this, I would suggest dimming the HMI all the way down first. and then flicking the breaker. Now the next step is pretty obvious, but I've got to mention it anyway. Before you disconnect the link, make sure you turn both generators off. Now in this scenario, I've got 3 lights running off the same generator, and I've deliberately picked 3 different size lights. I've got a Forza 500, an M18, and a 2.5K Fresnel. Now we've got to the end of the day and we want to turn the power off. Now if we just go around flicking on off switches, we could send a power surge through the system and blow up some electronics. So what's important is you want to gradually bring the power down. You don't want to have any surges. So the correct way to turn off is to turn your small lights off first, your large lights off last. Now also to help you ease down the load, use the dimmers. So dim the light down and then flick the breaker off. Get to the next light, dim the light down and then flick the breaker off. So think of it like an aeroplane coming into land. You want to gradually bring it down. You don't want to crash it. Okay, so I'm going to go through, have a listen to the generator noise as I cycle everything down. Now here's where a lot of people go wrong. Okay, so at the moment I've got, what's this, 5.25 kilowatts of lights here, 5.25 kilowatts. And that's allowing for the power factor in the ballasts. All right, so that is under the constant load rating of the generator. Okay, so yep, no worries, can fire them all up. But here's what a lot of people forget. Power cables. Okay, if I've got these 30 meters or 60 meters in different directions, you've got line loss over your power cables. So that's where monitoring comes in handy. A lot of these generators have monitors on them that tell you how much power is actually being pulled. So you can use that to check that you're still under your constant load ratings when you're running power extension lead. Now, quite often I'll have to go around a set after lunchtime or usually towards the end of the day and slightly dim my HMIs to keep everything under that constant load rating, because as the cables heat up, I get resistance and that increases the power draw. All right, so before we go, just some quick advice for young gaffers based on hindsight, based on mistakes that I've made. Okay, so 17 years ago, I bought my first generator and I bought this to run a 1.2K HMI. Here's the mistake I made. I didn't test the HMI first to find out what its actual power draw was. And that's how I learnt about power factor correction, because the ballast wasn't power factor corrected. So I ended up having to buy a second one of these 2 kVA so I could link them together to run the HMI. So test your HMI first before you buy a generator. Number 2, at least once a year, run all of your HMIs off your portable generators. Okay, and here's why. You can have a fault in a HMI, like a capacitor not working properly in the ballast or a faulty igniter pack in the head. And those faults might not be noticeable when you're running off mains power because you've got a power grid behind you. But having a big inrush current on a light because it's got a faulty capacitor is something that will shoot you in the head when you're trying to run it off a small motor. Okay, so that's something to test for. And while you're at it, you might as well write down what the power draw is on the ballast. So that way, if you've got a chute, say for example, I have 2 of these 3 kVAs and I have this 7 kVA, and I need to run 2 4Ks. The most power efficient ballast I've got, I'll run it off the 2 3 kVAs. The least power efficient will run off the 7. Okay, so you can manage your stock a bit better. I'm Andrew Locke. See you on the next episode of Gaffer and Gear. Don't forget to subscribe or click like.